Hi everyone. In this video, I'm going to talk about how to analyze a physics graph, which is going to include plotting the data points, drawing the line of best fit, calculating the slope of that line, and then discussing what that means. The example says, using the information in the data table, construct a graph on the grid provided. Right off the bat, I can tell plotting the time will be easy because I just see the numbers 0 through 5 seconds, and those are clearly marked for me on the horizontal axis. Position might be a little bit more challenging because I see numbers like 2.3 and 1.8, and those are not clearly marked for me. What I want to do is figure out how much each of these little boxes is worth. And so I'm looking at this interval from 0 to 1 meter. That whole thing is 1 meter. And there's 5 boxes, 1, 2, 3, 4, 5. So I'm going to divide that into 5. I can put that into my calculator. If you put that into your calculator, you should get 0.2. And what that means is each of these little spaces is 0.2 meters. In other words, we're counting by 0.2s. You don't have to label it like this, although you can if it helps you, but it's good to know what each space is worth so that you can use that when you're plotting your points. This is what my graph looks like, and I'll go over a few of these points with you. So at 0 seconds, which is right here, my position was 3 meters, so I went all the way up and then plotted my first point here. At 1 second, which is right here, my position was 2.3 meters. So I go up to 2, and then this is 2.2, and this is 2.4. So I just went right in the middle of 2.2 and 2.4. And that's kind of the strategy I use to plot the rest of my points. The next thing we're supposed to do is draw the line or curve of best fit. Now, on the physics regents, it's usually your job to decide if it should be a line or a curve. In this case, I'm definitely going to be drawing a line. My data is not perfectly in a straight line, but it's pretty close, and the data in a real experiment will never be perfect. So I can see that it generally follows the pattern of a straight line, so that's what I'm going to be drawing. First, I'm going to give you an example of what not to do. You should not connect each individual dot to the next dot like this. This is correct in some science classes, but in physics, you will not get credit for doing this. This is what you should do instead. We want a line of best fit, which means it's one straight line that goes through the majority of the points. So I can see that my best fit line goes through this point, and this point perfectly. And then there are a few others that are pretty close. Out of these other 3 that are close, 1 is on one side of the line and the other 2 are on the other side. So you wouldn't want all of your extra points to be down here or all of your extra points to be up here. So you just kind of are aiming for the middle. And you can see that mine starts at my first point and ends at my last point. That is not always going to happen. Sometimes the beginning or the end point are going to be a little bit off and you'll just kind of not hit them at all. And that's totally fine. But in this case, I ended up hitting the first and the last points. The next thing we're going to do is calculate the slope of our best fit line, which means I need my slope formula. So there's more than one way to do it, but this is the slope formula that I think most students are most familiar with. So slope equals y2 minus y1 over x2 minus x1. And that means that I need to choose my points that I'm going to use. I chose my first and my last point, and I'm allowed to do that because those are the points that my best fit line goes through. So I could have also chosen this one as one of them. That would have been fine. But make sure you're not choosing anything that's not on the line. So when I go to plug in my values, y2 and y1 are based on my position values because this is the y-axis. So my second point had a position, or a y value, of 0.5. So that's how I got this number. My first point had a position of 3, or a y value of 3. So that's how I got that number. My second point, x2, so my second point had an x value of 5, which is how I got this. And my first point, x1, had an x value of 0. So that's how I got that. I can plug the numerator and denominator into my calculator separately. 0.5 minus 3 gives me negative 2.5, and then 5 minus 0 is 5. If I do negative 2.5 divided by 5, I get my answer, negative 0.5 meters per second. I put in meters per second as my unit for the slope because I'm literally dividing some number of meters on the y-axis by some number of seconds on the x-axis. A meter divided by a second is meters per second. So that's my answer for question 3, the slope of the line. Question 4 asks, what physical quantity is represented by the slope of your graph? How do you know? A physical quantity is something like this: distance, displacement, speed, velocity, or time. Throughout the year in physics class, we're going to have many, many more, but these are some examples of physical quantities we've learned about so far. And out of these physical quantities, only 2 are measured in meters per second, speed and velocity. The big difference between them is that only one of them is allowed to have a negative number. So since my slope is negative 0.5, that's going to tell me that the slope represents velocity.